In today's presentation, we'll discuss about the last topic on optical network, that is optical network deployment, where there are few topics already we discussed under network deployment. Few topics were remaining, where I will discuss in today's presentation access network and about LAN, that is local area networks. In the previous presentation, there are few topics under access network we discussed. I'll just briefly go through again about the few topics under comes under access network. So first of all, I'll just redefine again the access network, the definition. So how we can define the access network? It is an element of a public telecommunication network that connects the access nodes to either individual user or to the metropolitan area networks. So access network, it just need to connect to the users or any other particular network unit. So it can be considered as the last link in a network at a customer's premise or the first point connection to the network infrastructure. So generally the access network, I can say it is just a link to the customer's premise or to the network infrastructure. So where it can useful to access the different nodes by the users or different connections can be established through the help of access network. So if I take the access network, how exactly this transmission is going to be deployed with respect to the optical fiber. So there are few strategies which we need to understand to how this access network transmission deployment can happen. So that is always going to be happen with respect to the one, there should be existence of office or exchange, we can also call it as. So access network can be provided from a single point, can be located at the local exchange or hub or point to point presence, that is POP. All are same, either local exchange or local office or hub, or also point to point exchange or point of presence, POP also we can call it for any particular network. So this is the initial point where it need to be connected, and this is inside the user point terminal, so where the access network is going to be connected. So there exists intermediate connection through the help of either optical fiber as a medium or any other particular medium which I need to discuss in this particular access network. One is HFC, that is hybrid coaxial cable, or DSL, that is digital subscriber line, which we will call it as, where twisted pair copper cable are going to be used, or otherwise satellite or Wi-Fi or Wi-Fi maximum, or last option is optical fiber, that is where the access network can be happened with, through the help of optical fiber also. So this different whatever I just mentioned, the different analogies or different connection settings from the local exchange to the any user. So we can discuss that in terms of different type of access network and how it can be happen with the help of HFC, or with the help of DSL, or through the help of optical fiber or Wi-Fi maximum, and its particular the speed upstream or downstream, or which standard it belongs to. So this is all the table which is going to be mentioned about it. So if I take hybrid fiber coaxial cable, this can have something around 100 to maximum 160 also mbit mbps, we can take it, but this is the standard is defined by American National Standard Unit, which is considered with respect to ANSI, it is defined HFC. But we have another set is a DSL, digital subscriber line. It is using a copper cable, where a symmetric digital subscriber line can have different varieties. It can be used with a twisted pair, where the speed is very limited. So it is always Indian standard telecommunication unit which can be used, or sorry, international telecommunication unit can be used as a standard to define this DSL. So or very high speed DSL can also be used the length also it is dependent in terms of kilometers, but HFC is very small, can also be defined with this very small. This is bit in terms of kilometers, this is in terms of 300 meters. HFC is in terms of very minimum length which can be considered, that is around 300 meters, but here it is kilometers can be existed between the DSL, but it is having a little bit transmission upstream or downstream. The speed of the unit or the network, how it is connected with speed, which will be quite low compared to the hybrid fiber coaxial cable, or comparing to the DSL. So speed is get a little bit low. But if I coming to the other options like wireless connections to make access network through satellite, so it can have its own range length, or it can be defined also. But speed is again it is also have in terms of limited addition with respect to the speed. But if I coming into the optical fiber, we can have good speed, gigabyte information can be transmitted, large information and transmitted, and also for long haul distance can also be covered with the help of optical fiber. So access network can make it in a different transmission medium, where along with I can take optical fiber is also one of the medium can be used to make access the network. So electrical or network hub can be arranged with the help of optical fiber. So that's why the network hub analysis with respect to the optical fiber is also going to be very important concept. So I'll just discuss one by one. However, in access network, I mentioned HFC or DSL or even the optical fiber. However, we know, but also have to be discuss all these particular point, how it can establish the connection from the local office into the users. So I'll start with one connection with the help of a hybrid fiber coaxial cable TV network. So HFC is a combination of optical fiber and coaxial cable. So HFC, if I say, that is hybrid fiber coaxial cable. So this consisting, actually we have optical fiber and also the coaxial cable which is existed to make the connection from office into the users. So the cable, basically HFC cable consists optical fiber and coaxial cable. That is the basic combinations. So HFC network provide a cable TV services to business unit to the 500 to 2000 residential users. So at the receiver side or user side, we can have 500 to 2000 home can be defined here. So optical node employed electronic optoelectronic transceiver to connect the optical fiber and coaxial cable. So we have coaxial cable, we have optical fiber in this sense. So I have to connect these together, because this is optical fiber, very small set of light which is going to become that need to be connected to coaxial cable. So optical node is required to connect from optical to the electronic transceiver is required here. Conversion is required. So optical node is consisting of optoelectronic transceiver. Okay, and also in this network we are using something RF amplifier. So network RF amplifier are used as a trunk line amplifier to amplify the signal power on the coaxial cable. So in the coaxial cable, signal power may be reduced, so that is we are amplified with the help of line RF amplifier whenever it reaches to the users. So it need to be amplified and it need to be given or served to the different homes or users. So next, after HFC, we can say about DSL. This is also one of the through the help of again coaxial cable, we can connect the local office, that is exchange, to the users, where we can connect through the help of digital subscriber line. So digital subscriber line provides a broadband access over exciting twisted pair copper telephone lines. So basically we are using telephone lines, that is twisted pair cable, which employs a large number of 4 kilohertz spaced orthogonal subcarriers. It consisting of 4 kilohertz spaced orthogonal subcarriers, and DSL which enables the transmission rate around 100 Mbps. So DSL normally employs with the 100 Mbps as a speed. That is what we can take it from the DSL. So next point, adding to the access network, optical fiber access network. So there should be from the user to the local exchange. Normally we are defining this connection or a deployment connection, optical deployment connection. Normally we have two sections. So that is in terms of feeder and also distribution section we are going to be defined. So that is shown in the first diagram A, and the second diagram is also gives the deployment strategy from the local exchange into the user, how it can be happen. So I'll discuss that second diagram later. I'll just go into the first diagram. So in first diagram we have on local exchange we have RN is nothing but it is a remote node, and also we have NIU, that is a network interface unit. So between local exchange to remote node we will call it as feeder unit or feeder side, and between the remote node to network interface unit we will call it as distributor. So between this feeder and the distribute section, so normally which is going to be happen the communication from the local exchange into the user side. So one is going to be feed, another one is going to be distributed. So optical fiber access network can be divided into feeder and distribution section, that is what I just mentioned. And NIU is nothing but the network interface unit enables the communication between the devices that use different protocol by providing a common transmission protocol. So this NIU, what is the use of this? So network interface unit will communicate the device that use some different protocol to provide a common transmission protocol. It will take common communication protocol from the local exchange into the user, so that is controlled with the help of NIU. And we can go with the second diagram, which consisting however I said it is different deployment strategies. So normally from local exchange office, this deployment normally with respect to the optical fiber access network, how it can be made it, the three deployment category we can make it, that is with respect to optical fiber. However we mentioned access network can be mentioned in do the connections in a different manner like HFC or DSL, and now we are discussing about optical fiber. Under that, if I suppose I used optical fiber, the deployment strategy based on these three different categories, that is how it is mentioned in the second diagram B here. So one layer I can define it in terms of local exchange, local office, also we can call it as LO. Next we can have is a curb or cabinet, that is consisting of ONU. However, that ONU is also in the premises end, but this in terms of in the curb end, if I say the ONU is nothing but it is optical network unit, and towards to the premises or user side we will have NIU, that is network interface unit. So normally the connection or deployment strategy with the two cases can happen. So one is FTTC and FTT cap. So FTT cap is nothing but fiber to the cabinet. This is what we say, fiber to the cabinet, and FTTC is fiber to the curb, we can say. So either fiber to the through the cabinet, fiber to the cabinet or fiber to the curb, which is going to be defined in this particular section, where ONU is the mainstream for the curb or cabinet unit. So ONU is nothing but optical network unit, where it will make the connection at the curb region itself. But if I coming to the second section where the deployment can happen with the three regions or three layers of strategies, if I consider, so there will be an FTTB and FTTH, that is nothing but fiber to the home and fiber to the building, where the ONU which is existed towards to the home or towards to the premises or towards to the building. That is what the meaning, where ONU is situated along with the NIU or which is very close to the user or premises end. So in between there should be a connection need to be established from local APIs to the optical network unit. Then optical network unit just feed the information into the network interface unit NIU. So later it will reaches to the user end, where the premises end which is mentioned however though here. This is how I just make the deployment strategy with respect to the optical fiber access network. So next type of access network is, that is passive optical network. We can also use it, passive optical network. So this passive optical network, uh, nothing but I can define the optical fiber access network. However, I just mentioned earlier, the employing something a passive optical component and configured around a passive splitter or combiner is called passive optical network. So passive optical network is nothing but it is very similar to the optical network access network, but we are using something passive optical component to configure the to make the device as a passive optical network. So PON, which is the general structure of PON, which is shown here in this diagram. So the PON can be formed with the help of optical fiber access network. So PON, that is a passive optical network, serving a significant number of customers at the output device with an 1 cross n optical power splitter. So we have 1 into n number of optical splitter is required to split the information, or demultiplexing is required the from the premise local office to the towards to the premises end, normally if I want to say it. But the local office side, we need to have something like OLT, that is optical line terminator, which can be used for the termination purpose of a light information passed. Then it is split into the many number of n number of units. Then n number of units is going to be reached with respect to the optical networking unit, where the premises is going to be defined later. Nothing but in between the stages which we can define also ONU, and between the local office exchange and ONU we can define all these passive optical network component. So this is how just we are serving the optical fiber access network with the help of all these particular perspective of connections can be used to make entire the access network with a proper and better manner, where it can serve more amount of information also with respect to the optical access network. So PON, I just mentioned earlier, that is a passive optical network based on access networks can be classified normally into three sections. That is PON based access network, we are just classifying into the three categories, that is ATM PON, simply we can call it as APON. So ATM is a synchronous transfer mode, the PON, that is passive optical network. So simply we can call it as AP1. This one also we have a name as a broadband PON. We can call it as broadband PON. Another type is PON is Ethernet PON, EPON. We can call it as another name as Gigabyte Ethernet PON, GEPON. That is in terms of gigabyte. That's it. So another one is gigabit PON, only gigabit PON, GPON, which is going to be considered. So PON normally three types, that is APON, EPON, GPON. So if the question is related to PON, then we can explain these three categories like APON, EPON, and GPON. So I'll just look for AP1 first. Later I'll explain in the coming slides about EP1 and GP1. So AP1 PON means this which is utilized as synchronous transfer mode, that is ATM, which is using over PON strategy. So however, I just discussed PON strategy. Also we discussed about ATM earlier. So these are effectively using ATM over PON strategy will provide the AP1 structure. So this is normally consisting total in the output side 1 cross 32 splitter is required here. So RN is nothing but remote node. However, I mentioned earlier ONU is nothing but optical network unit. OLT is nothing but optical line terminator or termination unit, you can use it. So here there will be a 1 to 32 splitter is required, or combiner is also we can use it in the other way around to take, if in the action is doing in the reverse order, combiner is also I can consider. If I do in the reverse order from this to this splitter I can mention it, but total the distance which can be covered from OLT to ON with respect to AP1 is a total maximum of 20 kilometers distance can be utilized with respect to this type of PON to make long distance, but in between that the PON concept or structure can be established under optical fiber access network can take the range around 20 kilometers. So this is about AP1, how we can establish with respect to this diagram where we can mention it, how AP1 can make it. So next is another type of PON, that is Ethernet PON. We can call it as, simply call it as EPON. So AP1 cannot readily carry the internet protocol or Ethernet data packets which are required to be broken up and reassembled at the user terminal. So this is one of the disadvantage I can consider with respect to AP1. So this we can overcome, this problem can be overcome with the help of EP1. So here in EPON, IP packets transmission via Ethernet frames can be done. So frame by frame, which can be transmitted from the local office to the user side, how it can be transmitted. So normally there will be a splitter, we can have one to many we can consider, but here in this particular diagram for Ethernet PON, 1 to 3 user side, which is considered 1 cross 3. So at the splitter, the traffic is coupled to 3 separate fibers, each carrying all the same traffic, as you can see, 4 unit, 4 unit, 4 unit, or each splitter or each traffic which is carrying same traffic amount of traffic or information. So whatever we call it as, this is an downstream passing into this, upstream also we can call it in a different manner with respect to Ethernet PON. So here the remaining thing is our same OLT, that is optical line termination, and ONU also we can say it as optical network unit. So coming to the next type of PON is gigabyte passive optical network, that is GPON, which can be explained with respect to this particular diagram. So gigabyte PON can carry both ATM and Ethernet as well as IP packets. So here Ethernet IP, however, we mentioned earlier, that is Ethernet PON, but if I include ATM along with that, so it will form an gigabyte PON. So ATM Ethernet IP packets are mapped onto the GPON frame structure, then it is going to be passed. So this frame structure, GPON frame structure, which is includes all these Ethernet IP packets and ATM, hence it is formed and generic frame procedure, GFP, generic frame procedure, is usually employed both IP and Ethernet traffic. So GFP, that is generic frame procedure, for PON, calling it an GP1 encapsulation method. So GP1 encapsulation method called as GEM encapsulation method. So we are coming into the Ethernet packets, IP packets, traffic together over to the unit, or we'll call it as a generic frame procedure. So this encapsulation, call it as framing, the GPON encapsulation method and the ATM frames are combined using the GPON transmission convergence frame structure. So the combination, initially what we can have, the IP and Ethernet, whatever I mentioned earlier, IP and Ethernet traffic together, we can make it a GPON encapsulation method where it includes ATM frames. Then it can be called as GTC, that is GPON transmission convergence frame structure. So this encapsulation method with respect to this particular GPON shown in the next frame structure consideration over here, you can observe it. So GPON frames transmission, so we can have ATM frames, Ethernet and IP, which is taken together with respect to generic frame, that is both is encapsulated or overwritten, not encapsulation, that is just overwritten with respect to the GTC frame, however I just mentioned earlier. So GPON frame transmission, combined transmission of ATM and IP, ATM and Ethernet and IP are together just transmitted with respect to GTC frame. So then it is encapsulated, combined together with many GTC frames to form, and GEM frames can be formed. So this is what we call it as GPON encapsulation method. So then it is put into the in between the OLT to ONU. So then user side, this is the local oscillator side, sorry, local exchange side, where the connection can be established with where the encapsulation can be done. All the frames are encapsulated where it consisting of Ethernet, IP, ATM together in the frame structure and encapsulated. Hence, GPON encapsulation method which is considered with respect to GPON. So if I want to explain about GPON, the GPON frames transmission, we can mention it along with the encapsulation method, and also the previous diagram to say about what is GPON, which consists how it is going to be transferred with the split, how much split can be done. That is what about GPON. So under all these PON structure or concept, there is one flaw which can be taken. The different wavelength cannot be transmitted, or multiple values of information cannot be transmitted. Hence, to overcome all this problem, apart from the speed or network speed, everything, so the multiple wavelength to be transmitted, we can go with the wavelength division multiplexed WDM, passive optical network, that is PON. WDM, PON, we can call it as, we can have OTN as it was, OLT as it is in this side, and we can have this splitter or unitter, we can call it as, and also in the receiver side towards to the ONU we can have. So ONU with respect to the WDM, so this OLT can consisting of either WDM source or receiver should be required. With respect to the band pass filters can also be used, optical band pass filter. So optical fiber can be existed carrying many number of wavelength, multiplexed or demultiplexed wavelength can be considered. Then there will be a remote node do the operation of multiplexing or demultiplexing via both direction can be used. So one is multiplexing and another is demultiplexing can be done. So demultiplexing to this side, multiplexing to this side. So many wavelengths are split and passed into the optical filters and transmitter and receiver with ONU side, optical network unit side. So this is how we can make the WDM PON. So all these has with the different speed variations and for the distance also varying with the percentage of efficiency if I want to look it. So coming to the last topic, that is local area network, which we want to discuss. The full form is for LAN is local area network. LAN, which is usually confined to either a single building or a group of building contained entirely within establishment. So LAN is nothing but it is an connections established in a single building or a group of building or in an establishment. So this is what the LAN can be mentioned. So this basically work with respect to the network model of OSI or LAN modifications which is mentioned. So it is basically the network reference model for LAN is in terms of OSI model, but there is a small changes which is defined only for the two layers after the data link and physical, or some changes are nothing but with respect to we are including LLC, that is a logical link control layer which assembles and disassembles. Both can be done under LLC, either in terms of logical link control layers which assemble or disassemble the data frames or brackets, provides the appropriate address and error checking fields. Next, we can have the medium access control, that is MAC, which we can mention, that is another layer after LLC. So the data link layer and physical layer are divided into three structure as per the LAN for OSI comparing. So LLC is just mentioned logical link control, and we have another layer is MAC, that is medium access control. This layer which organizes the communication over the link. So the it just organizing the how the connection need to be established. In LAN, each node on the network can be directly connected to all others. Normally in the LAN, each node on the network can be directly connected to the all others can be happen directly. It can be controlled. So that is majorly LLC or MAC which will do that particular operation. The optical fiber LAN topologies are usually is a bus ring star. If I take the bus is bidirectional, it can have the four couplers can be used over here. This, however, I mentioned the network topologies in the earlier topic. So if I take the ring topology, if I consider it is an unidirectional, it is an circular in manner, and one-to-one connection and information passes and it will pass into the another section. Okay, the star is nothing but hub type of connections. From one central hub it will connect to the many terminator units or network units which can be mentioned. So this is how the LAN topology, normally it will have bus ring, and our topology can be used with respect to the connection oriented if I take with respect to these particular topologies. But this is where the diagram reference model, how the OS layer, I layer, where the last two layers are changed as per in terms of LAN model. So local area networks can design the MAC layer is very crucial in terms of LAN. How you can make the MAC layer arrangement that are basically with the help of three specific type of access protocol can be used under these particular layers. So three type of protocol, access protocol are: one is the random access protocol. Any random data can be taken, or in between any data is can be taken, and it is just can be passed into the unit, and directly it can go. Next is token passing protocols, or any users if I want to transmit, so token will be given to the ethernet, and it can be given into the ethernet unit, and it can be transmitted. The next one is time division multiple access protocol. So this is also very similar kind as I earlier mentioned with respect to the TM, time division multiplexing access protocol is also based on the time division, time slot or time unit, where we can define how much amount of information, or how much the information need to be passed into the from office into the user, or the networking nodes or units. So the optical fiber regenerative repeaters also can be used to restore the attenuated signal power in an optical fiber LAN. So optical fiber local area networking was centered on the fiber distributed data interface. So all the optical fiber LAN was basically there will be a center for LAN, which is we will call it as fiber distributed data interface, FDDI. Very simple manner. This can also be having optical fiber regenerated repeaters, where the restore attenuated power can be with respect to the optical fiber. So let us discuss about the what is fiber distributed data interface, FDDI. So FTDI was intended for the use as much at much higher data rate. So why FTDI is required? This use for higher data rates, 100 Mbps. So facility which is supported by the FTDI is these are the 5 points where it is support some of the facilities from this FTDI. 100 Mbps data transfers within 125 MB or MBOD transmission using 4x5 line code, or up to 100 kilometers of dual ring fiber can be used for a 100-kilometer distance. Up to 500 network nodes can be connected to this, up to 2 kilometers between the nodes, so one node to another node 2 kilometers. So this is how we can establish the difference. And time token passing protocol can also be used under FDDI. So these are some of the facility are based on the reasons why we can choose a FDDI is used over distributed data interfaces. So normally here there is the different layers. However, I mentioned the for LAN, what changes is only with respect to data link and physical layer, LLC or MAC or physical layer. However, if I take the physical layer is subdivided into two layers. One is PMD, another one is PHY, where the PMD is nothing but physical medium dependent. Physically medium dependent also can also have something like a single mode fiber PMD also possible. Physical medium dependent. So by which medium we are using, that is also dependent. BMD is decide that. Then is a physical layer protocol. It will just link the physical layer into the data link layer, so where MAC is required. So MAC is very important. However, I just mentioned LLC is a logical link control layer. The next, but MAC is very important. How it will going to choose their address into the connection, so it will make the connection to the higher layer. So MAC is however I just mentioned earlier, MAC is very important under LAN. So SMT is the last, that is station management, where it is very error is occur. So this is need to look, this station management is need to look any problem which is occurred in these particular layers, that is controlled by, that is looked by, all the data is just stored by in the station management. So this is entire the structure of FTDA, fiber distributed data interface. Under LAN you can expect FTDA as a very important question, or directly you can expect the explanation onto LAN also. So coming to the last point under FDDA, how the work is going to be done with the help of this, the two diagram which tells. The first diagram is the dual ring structure, where how the information is passing under the help of dual ringer. Two contrary rotating rings were employed here. So primary ring and secondary ring. So one ring is considered like this. So secondary ring is considered like this. So A and B, these are the names which is given for primary and secondary link or unit from user to the receiver side, so whatever it is. So employed which was capable of supporting many data rates, like however the information is passing either from primary ring or secondary ring, whatever the information is passed, so the speed is defined in terms of 100 mbps. The dual ring incorporate concentrated to form a dual ring of tree. So there is a dual ring here, two rings are existed, so dual ring tree is formed here. So the dual ring tree structure, which is you can establish or looking into the diagram A. But if I look into the second diagram, there is something break, cable break is happened under both the cases. Normally the network operation was normally designed to the primary ring. So normally the information can always pass with respect to the dual ring in the primary ring. If primary ring is not working, then secondary ring will work. If both is broken, however, if the ring was broken, then transmission was switched to the secondary ring. So secondary ring, if both is broken, so information is passed from here to here and it is established. It cannot move into this particular unit. So that is what the observation, what from the secondary to primary, primary to secondary, and it will reach to the destination. This is how the information, even though the ring configuration, any fault is detected, then also there will be an establishment connection can be happened with respect to the LAN. So these are the advantages with respect to FDDI. Fiber distributed data distributed unit, if I take it. So that is the advantage with respect to the LAN. So here we ended up with the module number 5, optical network. So with all these concepts, there are important concepts under the network deployment unit also. So either man or the first topic, whatever we discussed under this particular topic, along with the access network, you can expect few question, and also in terms of LAN also. Thank you for listening.